So the first question asks us to show this identity. Sin 2x plus cos 2x minus 1 equals 2 sin x into cos x minus sin x. So you can either choose the left-hand side or the right-hand side. So I'll take the left-hand side. I'm basically going to take the identity that sin 2x equals 2 sin x cos x and cos 2x equals 1 minus 2 sin squared x. Then I'm going to drop the minus 1. So I've basically rewritten this by using the left-hand side, and these identities that I just used can be found in the data booklet for Mathematics AA. Now what I'll do is cancel this positive one with this negative one, and I'm going to be remained with 2 sin x cos x minus 2 sin squared x. Then I'm going to factor out 2 sin x because it's common in both of these terms, and then I'll get 2 sin x into cos x minus sin x, which is my right-hand side. The next part asks us to solve, hence or otherwise, sin 2x plus cos 2x minus 1 plus cos x minus sin x equals 0 for this domain. Firstly, since we've already looked at this part, which is your left-hand side in the previous question, we can simply replace whatever is over here with 2 sin x cos x minus sin x, and then we can remain with cos x minus sin x, and this is equal to 0. Remember that for you to factor out anything, you must find them common in both of your terms or in the number of terms that you have in your equation. So over here, since we have 2 sin x into cos x minus sin x plus cos x minus sin x, the term cos x minus sin x is common in this equation. So we can factor out cos x minus sin x and remain with 2 sin x plus 1 because this is being multiplied by 1 times cos x minus sin x equals 0. Now for this to hold true, either 2 sin x plus 1 equals 0 or cos x minus sin x equals 0. In the case that 2 sin x plus 1 equals 0, 2 sin x equals minus 1 and sin x equals negative a half. If we look at our unit circle, that means that this angle would only be lying in the third and the fourth quadrants. So since we know with special angles, for sin x to be a half, your value of the angle will be pi over 6. Your first answer would be pi plus pi over 6 for the third quadrant and 2 pi minus pi over 6 for the fourth quadrant. The last one is when you have cos x minus sin x equals 0, in which case you can move sin x to the other side and get cos x equals sin x. This will only hold true when both cos x and sin x have the same sign. So in the first quadrant, both of them have a positive sign, and in the third quadrant, both of them have a negative sign. Again, via special angles, we know that x would be pi over 4 in the case that both cos and sin were going to be equal. So the first case, where in the first quadrant we can leave it as pi over 4, and in the third quadrant we can simply rewrite it as pi plus pi over 4. Therefore, x will be 7 pi over 6, 11 pi over 6, pi over 4, and 5 pi over 4.